This is Catherine Morgan-Nance. Welcome back. In this video, we'll apply what we've learned so far about the net present value method. Before continuing with the example you see on your screen, I recommend you obtain the two present value tables we reviewed in a previous video. Here are the facts. ABC Company has been offered a 5-year contract to provide component parts for a large manufacturer. Cost and revenue information is provided on the screen. These amounts are the project's cash outflows and inflows. Furthermore, ABC Company's discount rate is 10%. Finally, as we discussed previously, we'll also assume that at the end of 5 years, the working capital will be released and may be used elsewhere. Should ABC Company accept this contract? Please take a moment to jot down this information before continuing. And as you're considering the facts, don't forget to identify whether each cash flow is an annuity or a single payment. Along with identifying whether each cash flow is a single payment or annuity, we will need to compute the annual net cash inflows from operations. I think you'll agree it's pretty easy. Simply subtract annual expenses from annual revenues, just like you've done many times before. You should have calculated annual net cash inflows of $80,000. Before we move on, what type of payment is the annual net cash inflows? A single payment or an annuity? We'll answer that question in a couple moments. Before getting started, it is helpful to organize your thoughts. I suggest you create a table similar to what you see on the screen. Each type of cash flow will be listed in a row, columns identifying the following information for each type of cash flow. First, whether the cash flow is an annuity, that tells you what table to use. Second, when the cash flow occurs, the number of years. Third, the amount of cash flow and whether it is an outflow, negative in brackets, or an inflow, positive amount. Fourth, the appropriate present value factor. And fifth, the present value of the cash flow, which is equal to the amount of the cash flow times the present value factor. In our example, since the investment in equipment, $160,000, and working capital, $100,000, occur immediately, the discounting factor used is 1. They are also single payments since they occur only one time. As we shall see shortly, ABC Company will recover the working capital at the end of the project in 5 years. If you have not done so already, now is the time to refer to the two present value tables we discussed earlier. Did you decide that the annual net cash inflows of $80,000 were an annuity? Remember, the words annual or yearly indicate a cash flow is an annuity. The present value factor for an annuity of 5 years at 10% is 3.791. Therefore, the present value of the annual net cash inflows is $303,280. Notice that this amount is less than the gross value of the cash flows of $400,000 due to the impact of compounding interest. Please refer to the Khan Academy's Time Value of Money video if you need a refresher on this topic. Relining the equipment is a type of equipment maintenance. It is a cash outflow that occurs one time, 3 years into the project. Thus, we'll use the present value table for a single payment rather than the annuity table. The present value factor for 3 years at 10% is 0.751. Therefore, the present value of the cost of relining the equipment in 3 years is $22,530. Two more cash flows occur, both at the end of the project in 5 years. First, the equipment will be sold for a salvage value of $5,000. Secondly, the working capital will be released. We assume the original amount invested is released, that's $100,000. Please make a note that you will not always be told working capital is released. You should just assume it will occur, okay? So back to the example. Both of these amounts are cash inflows and both are single payments. The present value factor for 5 years at 10% is 0.621. Therefore, the present value of the salvage value of the equipment is $3,105, and the present value of the release of the working capital is $62,100. Now we can net together the present values of all the cash inflows and the cash outflows. We see that the net present value of this contract is $85,955. If the net present value were exactly zero, it would mean the rate of return generated by the project is exactly 10%. In this case, since the net present value is positive, it means the rate of return generated by this project is greater than the discount rate of 10%. The positive net present value suggests that ABC Company should accept the project. Now you try calculating net present value for a similar example. Brown Associates has been offered a 4-year contract to supply the computing requirements for a local bank and requires a 14% return. Project cash flow information is provided for Brown Associates on the screen. First, remember to calculate the contract's annual cash flows, then calculate the project's net present value, and 4 potential answers are provided for you on the next slide. So what do you think? Which of the following amounts is the net present value of the contract with the local bank? Pause your video for a moment before you go on to the solution. The net present value of Brown's bank contract is $28,230. Should Brown accept the contract? The answer, of course, is yes, because the net present value is greater than zero. Let's walk through one last example. In decisions where revenues are not directly involved, managers should choose the alternative that has the least total cost from a present value perspective. Assume the following facts. Home Furniture Company is trying to decide whether 1. to overhaul an old delivery truck, or 2. trade it in and purchase a new one. The company uses a discount rate of 10%. The information pertaining to the old and new trucks is as shown. Notice that the two amounts are provided for salvage value on the old truck. If the old truck is fixed and used for 5 more years, its salvage value will be $250 at the end of its life. However, if it is traded in now for a new truck, the old truck's salvage value will be $9,000. Make a note of this. The salvage value of the old truck as a trade-in now is treated as a reduction in the cost of the new truck. Pause the video and take a few minutes to calculate 2 net present values. You will compare 1. the net present value of keeping the old truck with 2. the net present value of the decision to trade the old truck in and buy the new truck. We'll look at the solution for this least cost decision next. To solve this problem, you will use both the single payment and the annuity tables. Do the values shown on the screen agree with your computations? The present value factors are found in the 10% discount rate column. The project duration is 5 years, and payments include both annuity and single payment types over those 5 years. The net present value of overhauling the old truck is a negative $42,255. The net present value of buying the new truck is negative $32,883. Notice that both net present value numbers are negative because there is no revenue involved. This is a least cost decision. The net present value in favor of purchasing the new truck is $9,372. Good job working through the net present value examples with me. I hope you're confident about your understanding of the time value of money, and specifically the net present value method. Take a break and join me in the next video where we discuss how to choose between projects that return the same net present value.